Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm Anna.
And I'm Avery. Today is Tuesday, January 20th, 2026, and we've got a fantastic lineup of stories covering everything from solar storms to Chinese space technology and some fascinating discoveries about how young stars shape their cosmic neighborhoods.
That's right. We're going to dive into some breaking news about the sun's latest outburst. There's been quite a development there that Aurora chasers definitely need to hear about.
Plus, China continues to make impressive strides in reusable rocket technology with the Long March 12B, and we'll get a sneak peek at their upcoming Xuntian space telescope that's set to rival some of the best observatories in orbit.
We'll also journey into the Orion Molecular Cloud to see how baby stars are literally carving out their homes in space. Check out this week's busy launch schedule and explore a fascinating new theory about how some exoplanets might protect themselves from deadly radiation.
So grab your coffee, settle in, and let's get started with today's Astronomy Daily.
All right, Avery, let's jump right into our top story. And this one's developing even as we speak. The sun threw a massive tantrum this weekend, and Earth is already feeling the effects.
That's right, Anna. On Sunday, January 18th, the sun unleashed a powerful X.1.9 class solar flare from sunspot region AR4341. For our listeners who might not be familiar, X-class flares are the most powerful category of solar eruptions, and this one came with a particularly energetic friend.
A coronal mass ejection, or a CME, right?
Exactly. This CME was what forecasters call a full halo event, meaning it was aimed directly at Earth. The interesting twist here is that it arrived much sooner than predicted. Space weather forecasters initially expected it to hit sometime within 24 hours of the flare, but it actually slammed into Earth's magnetosphere yesterday, January 19th at 2:38 p.m. Eastern Time.
And I'm guessing from the reports I've been seeing, this wasn't a gentle arrival.
Not at all. The CME triggered severe G4 geomagnetic storms. According to NOAA's Space Weather Prediction Center, this is actually a pretty rare event. We're also dealing with an S4 severe solar radiation storm that's ongoing.
Now, for those wondering why this matters, let's talk about what makes a CME geoeffective or not. It's all about magnetic field orientation, isn't it?
That's the crucial factor. When a CME arrives, if its magnetic field is oriented southward, what scientists call a negative BZ component, it can connect with Earth's northward pointing magnetic field. Think of it like opening a door. The southward orientation essentially allows solar wind energy to pour into our magnetosphere, triggering geomagnetic storms.
And in this case, that door was wide open.
Exactly. Data from the DSCOVR and A spacecraft, which monitor the solar wind upstream of Earth, confirmed that southward BZ component. That's what made this storm so potent.
So what does this mean for people on the ground? Obviously, there's the spectacular side with auroras, but there are practical concerns too.
Right. The good news is that this storm could push the northern lights much further south than usual. According to NOAA scales, G4 storms can make auroras visible as far south as Alabama and Northern California. But there are some downsides. These storms can disrupt GPS navigation, affect satellite operations, increase atmospheric drag on spacecraft, and potentially impact power grids and high-frequency radio communications.
And the flare itself caused immediate problems when it erupted, correct?
Yes, the X.1.9 flare triggered strong R3 level radio blackouts across the sunlit side of Earth, with the Americas taking the biggest hit. Radio blackouts happen because the intense X-rays and extreme ultraviolet radiation from the flare ionize the upper atmosphere, disrupting radio signals.
For our Aurora chasers out there, what's the forecast looking like?
Well, geomagnetic storm conditions are expected to continue through at least today, January 20th. The best viewing times are typically between 10 p.m. and 4 a.m. local time. Of course, you'll want to get away from city lights and find the darkest location possible. And keep in mind, you need clear skies to see them.
The timing is interesting too, isn't it? We're well into solar maximum.
We are. Solar cycle 25 has been particularly active, and we're seeing the effects. The sun has been consistently active throughout late 2025 and into 2026, with multiple X-class flares and CMEs. This is exactly the kind of activity we expect during solar maximum.
It's yet another reminder that our star is a dynamic, powerful force. What's fascinating to me is how much we've learned about predicting these events, even if this one arrived earlier than expected.
Absolutely, space weather forecasting has come a long way. But CMEs are still notoriously tricky. Their speed, direction, and crucially, their magnetic orientation all factor into how they'll interact with Earth. We often don't know the full picture until spacecraft like DSCOVR sample them directly when they're almost at our doorstep.
Well, if you're in the northern tier states of the US or Canada, keep your eyes on the sky tonight. This could be a spectacular display.
Shifting gears from solar fireworks to human engineering, let's talk about China's latest achievement in reusable rocket technology. The China Aerospace Science and Technology Corporation has successfully conducted a static fire test of the Long March 12B.
This is China's follow-up to the Long March 12A, which we covered when it made its maiden flight back in late December 2025, right?
Exactly, and if you recall, that first flight was partially successful. The second stage successfully delivered its payload to orbit, but the reusable first stage crashed near the intended recovery area in Gansu province. So there's definitely been some lessons learned.
Let's talk specs. What can you tell us about the Long March 12B?
It's a fairly substantial vehicle. The rocket stands approximately 70 meters tall. That's about 230 feet, with a diameter of 4 meters. Both stages use liquid oxygen and kerosene propellants, which is interesting because it's the same propellant combination that SpaceX uses in their Falcon 9.
And in terms of capability?
In its baseline configuration, the Long March 12B can lift about 20 metric tons to low Earth orbit. That puts it firmly in the heavy-medium lift category. When fully fueled, the entire vehicle has a liftoff mass of around 700 tons.
So what exactly did this static fire test accomplish?
The test, which took place Friday at the Jiuquan Satellite Launch Center in northwest China, was all about validation. Ground teams ignited the first stage engines and sustained combustion for a period while monitoring performance and control parameters. They were verifying fueling procedures, ignition sequences, and making sure all the propulsion and support systems worked smoothly under planned conditions.
And the reusability aspect, how does that work?
This is where it gets really interesting. The first stage is designed to separate from the second stage during flight, then flip itself around for re-entry using aerodynamic grid fins for guidance. Picture those waffle-like fins you see on Falcon 9 boosters. Then it uses deployable landing legs to touch down vertically at a designated landing zone.
So it's very much following the SpaceX playbook.
It is, though China has been developing this technology independently. The goal is the same though, reusability to cut mission costs and increase launch cadence. This is especially important for China's commercial space sector and their growing satellite constellation projects.
And you mentioned the Long March 12A's landing attempt failed. Are they incorporating what they learned from that into the 12B?
Absolutely. Engineering teams are still investigating what went wrong with that December landing attempt. And the lessons from that mission are being fed directly into refinements for the Long March 12B's re-entry and landing systems. That's actually a really important part of the development process.
So when might we see an actual launch of the Long March 12B?
Based on this successful static fire test, we're probably looking at flight tests in the near future. They still need to do more ground testing and verification, but successful engine testing is a major milestone on the path to orbital flight.
It's interesting to watch multiple countries and companies working on reusable rocket technology. It really does seem to be the future of spaceflight.
No question. When you can land and reuse your first stage, which is the most expensive part of the rocket, the economics of space access change dramatically. China positioning themselves with both the 12A and 12B shows they're committed to competing in this arena.
Staying with China's space program, let's look ahead to what could be one of the most capable space telescopes ever launched. The Chinese Space Station Telescope, known as Xuntian, is gearing up for launch as soon as early 2027.
And scientists just completed something pretty important. A full end-to-end observation simulation to test how the telescope will perform once it's in orbit.
Let's start with the basics. How big is this thing?
Xuntian features a 2-meter primary mirror. That's about 6.6 feet across. For comparison, that's slightly smaller than Hubble's 2.4-meter mirror. But here's where it gets interesting. Xuntian is designed specifically as a survey instrument, and in that role, it's going to be far more capable than Hubble.
How so?
It's all about field of view. Xuntian's field of view is about 300 times larger than Hubble's. That means it can survey the sky much more efficiently. Combine that with a 2.5 billion pixel camera and the ability to observe from near ultraviolet to near infrared wavelengths, and you've got yourself an extremely powerful sky surveying machine.
That's impressive. What will it be looking for?
The science goals are pretty ambitious. According to the National Astronomical Observatories under the Chinese Academy of Sciences, Xuntian should make major contributions across multiple fields: cosmology, galaxy formation and evolution, the structure and evolution of our own Milky Way, and studies of stars and planets.
I've also heard it might help us understand dark matter and dark energy.
Exactly. Those are two of the biggest mysteries in astrophysics, and a wide-field survey telescope like Xuntian is perfectly suited to contribute to that research. By mapping large areas of the sky and observing how galaxies cluster and move, scientists can gather evidence about the nature of dark matter and dark energy.
Now, what makes Xuntian really unique is how it will operate in relation to China's Tiangong space station, right?
That's one of the coolest aspects. Xuntian will fly independently in low Earth orbit, co-orbiting with Tiangong, but doing its own thing. However, and this is the really neat part, it's designed to dock with the space station when needed.
So astronauts can service it.
Exactly. Just like NASA astronauts serviced Hubble 5 times between 1993 and 2009. According to recent video from China Central Television, astronauts will be able to conduct spacewalks to maintain, repair, or even upgrade the observatory. This is a huge advantage because it extends the operational life of the telescope and allows for technology upgrades over time.
That's actually brilliant. Hubble's servicing missions turned it from a disappointment into one of the most productive scientific instruments ever built.
Absolutely. And China clearly learned from that example. Being able to service a space telescope in orbit is enormously valuable.
Tell us about these simulations they just completed.
The research team built what they call an end-to-end simulation suite. Basically, they created mock observations that replicate the expected instrumental and observational conditions. They tested both the optical systems and other observation systems to evaluate the telescope's overall performance before it ever leaves the ground.
That makes sense. Better to find problems in simulation than after launch.
The results were published in the journal Research in Astronomy and Astrophysics in early January. This kind of validation work is crucial for a mission of this scale and complexity.
When you say early 2027, how firm is that timeline?
It's a no earlier than timeline. These large space telescopes are complex beasts, and schedules can slip. But if everything stays on track, we could see Xuntian launching on a Long March 5B rocket sometime in the first half of 2027.
It's going to be really interesting to see what Xuntian discovers once it's operational. Having another major space telescope conducting surveys will be fantastic for astronomy.
Next, let's head out to one of the most famous star-forming regions in our cosmic neighborhood, the Orion Molecular Cloud Complex. The Hubble Space Telescope has captured some stunning new images that reveal how baby stars are literally carving out space for themselves in the surrounding gas and dust.
This is such a beautiful topic. These are protostars, right? Stars that haven't quite grown up yet.
That's right. Protostars are young stellar objects that are still in the process of accumulating mass from the molecular clouds they're forming in. They haven't started fusing hydrogen into helium yet, which is what defines a main sequence star, like our sun. But even though they're not doing fusion, they're far from quiet.
They're quite energetic, actually.
Incredibly so. Protostars generate powerful winds and jets that shape their surroundings in dramatic ways. These jets and winds carve out bubbles and caverns in the surrounding gas, and astrophysicists have been trying to better understand this feedback process.
What's driving these jets?
It's a fascinating process. Material from the molecular cloud first forms a disk around the protostar. Not all of that material makes it onto the star itself. Some gets accelerated to high speeds along the star's magnetic field lines and shot out from the poles as focused beams of mostly hydrogen.
So they're like cosmic fire hoses?
That's a good analogy. And in addition to these focused jets, protostars also produce wide-angle stellar winds that flow in all directions. These winds from young stars are actually far more powerful than the solar wind from our sun or other main sequence stars.
What did the Hubble images reveal?
The 3 new images show protostars at different stages, all in the Orion Molecular Complex. You can actually see the cavernous shapes these young stars have carved out from the surrounding gas. It's quite striking visually, these dark, sometimes intricate structures against the glowing background of the nebula.
But there was a surprising finding in the research, wasn't there?
Yes, and it challenges some assumptions. Researchers found that the cavities carved by these jets and winds didn't grow larger as the stars moved through their later formation stages. You might expect the cavities to keep expanding over time, but that's not what they observed.
So what does that tell us?
Well, the Orion Molecular Cloud has been experiencing a declining star formation rate, and these protostars also have lower rates of mass accretion over time. Scientists initially thought maybe this could be attributed to the jets and winds carving out all the available gas. But the new findings suggest that's not the case. The cavity sizes weren't the limiting factor.
So something else is controlling the star formation rate?
Exactly. There must be other factors at play in regulating how quickly stars form and grow in this region. It's a reminder that even in well-studied regions like Orion, we're still learning the details of how star formation works.
I love that these images aren't just pretty pictures. They're revealing actual physics.
That's what makes astronomy so exciting. Every observation adds a piece of the puzzle. In this case, we're learning that the feedback from young stars through their jets and winds, while dramatic and visually spectacular, might not be the main factor controlling star formation in the region.
It's also interesting to think about our own sun going through this phase billions of years ago.
Absolutely. When the sun was young, it was in a cluster with its siblings, probably in a molecular cloud much like Orion. It would have had these same powerful jets and winds shaping the gas and dust around it. Eventually, the molecular cloud dispersed, the star cluster broke up, and the sun ended up as the solitary star we know today.
Orion is close enough that we can study these processes in detail, which is really lucky for astronomers.
Very lucky. At about 1,350 light-years away, it's one of the nearest large star-forming regions. We can resolve individual protostars and their surrounding structures, which gives us insights we can apply to understanding star formation throughout the galaxy and beyond.
All right, let's shift from natural cosmic phenomena to human-made space activities. We've got a busy week of launches coming up, Avery.
We do indeed. 7 launches from 6 different sites across the globe. Let's run through them.
The week actually started this morning with a Chinese launch, correct?
That's right. A Chang'e 12 rocket, also known as Long March 12, lifted off from Commercial Launch Complex 2 at Wenchang Space Launch Site in Hainan, China. This was at 7:48 UTC, carrying 9 SatNet satellites to low Earth orbit. The CZ-12 can lift about 12,000 kilograms to LEO, and this was a demonstration of China's commercial launch capabilities.
Moving on to tomorrow, what do we have?
Tomorrow, January 21st, we have Rocket Lab, launching from New Zealand. Their Electron rocket will be carrying 2 satellites for Open Cosmos as part of a secure broadband constellation being built in the UK. The mission is called The Cosmos Will See You Now, and liftoff is scheduled for 11:09 UTC from their facility on the Mahia Peninsula.
Rocket Lab has really established a solid cadence with Electron.
They have. This will be Electron's 80th mission. That's a remarkable achievement for a small rocket. The vehicle has proven itself reliable and capable, especially for these small satellite constellation deployments.
It's Wednesday that gets particularly interesting with the ESAR aerospace launch.
Yes, this is ESAR's second attempt to launch their Spectrum rocket from the Andøya rocket range in Norway. The mission is called Onward and Upward, which is fitting given that their first attempt in March 2025 failed shortly after liftoff due to an engine issue.
What's different this time?
Well, they've been investigating what went wrong on that first flight and making refinements. Spectrum is a 2-stage rocket powered by Aquila engines using propane and liquid oxygen. It's designed for the satellite constellation market and can lift about 1,000 kilograms to LEO. They're carrying several CubeSats for the European Space Agency's Boost program.
So fingers crossed for ESA on Wednesday. What else?
Wednesday is also when SpaceX has their first Falcon 9 launch of the week. They're launching 24 Starlink satellites from Vandenberg Space Force Base in California. Liftoff is currently targeted for 2:43 UTC on January 22nd, which is 6:43 p.m. Pacific time on the 21st.
Vandenberg has been busy lately.
Very busy. This mission will use booster B1093 on its 10th flight, landing on the drone ship Of Course I Still Love You in the Pacific. It's another example of SpaceX's routine reuse. This particular booster has previously flown 7 Starlink missions and 2 military missions.
Do we have a new Shepard launch from Blue Origin this week?
Correct. Blue Origin is targeting Thursday, January 22nd at 14:30 UTC. That's 9:30 a.m. Eastern. For New Shepard's 17th crewed mission, designated NS-38. This will be a suborbital flight from Launch Site 1 in West Texas, carrying 6 people past the Kármán line and into space for a few minutes of weightlessness.
New Shepard has really become a regular operation for them.
It has. The capsule will separate from the booster, which will return for a propulsive landing, while the capsule lands under parachutes with retro thrusters firing just before touchdown to soften the landing for the crew.
And we round out the week with
2 more launches on Sunday, January 25th. First, China will conduct a sea launch of a Jialong 3 rocket from the South China Sea. Details on the payload are still under wraps. They'll likely release that information after the launch. Liftoff is scheduled for 6:30 UTC.
sea launches are always interesting.
They are. The Jialong 3 is a 4-stage solid-fueled rocket that launches from a maritime platform. It's an interesting capability that gives China flexibility in launch azimuth and location.
And finally,
Sunday also brings SpaceX's second Falcon 9 launch of the week, also from Vandenberg. Another batch of 24 Starlink satellites heading to orbit at 15:17 UTC. This one will use booster B0088 on its 13th flight, another testament to booster reusability.
that's quite a week. 7 launches from 6 sites. It really shows how routine space access has become.
It does, and it's only going to get busier as more commercial constellations come online and more providers enter the launch market.
And may we wish them all successful launches.
Indeed. Moving along, for our final story, let's journey to distant worlds and explore a fascinating new theory about how some rocky exoplanets might protect themselves from deadly cosmic radiation.
This involves super-Earths, right? Those planets that are larger than our Earth but smaller than ice giants like Neptune?
Exactly. Super-Earths are actually the most common type of exoplanet we found in our galaxy, which makes understanding them really important. But here's an interesting problem. Many of these worlds might not be able to generate magnetic fields the way Earth does.
And magnetic fields are crucial for protecting a planet's surface from harmful radiation.
Right. Earth's magnetic field is generated by movement in our liquid iron outer core through a process called a dynamo. But larger rocky worlds like super-Earths might have cores that are completely solid or completely liquid, neither of which can produce a magnetic field through the same mechanism.
So how do they protect themselves?
That's where this new research from the University of Rochester comes in. They propose an alternate source, deep layers of molten rock called basal magma oceans, or BMOs, which exist at the boundary between a planet's mantle and core.
Molten rock generating a magnetic field.
It sounds surprising, but the key is what happens to rock under the extreme pressures inside super-Earths. The research team, led by Associate Professor Miki Nakajima, conducted laser shock experiments and quantum simulations to recreate the conditions deep inside these massive planets.
What did they find?
Under the crushing pressures found in super-Earths, we're talking planets 3 to 6 times the mass of Earth, molten rock becomes electrically conductive. And if you have electrically conductive material in motion, you can generate a magnetic field.
So these basal magma oceans could act like liquid metal cores, just using rock instead.
Essentially, yes. The movement of this electrically conductive molten rock could drive what they call a BMO dynamo.
And according to their models, these dynamos could generate magnetic fields that are actually stronger and longer lasting than those produced by core dynamos like Earth's.
That's remarkable. How long could these fields last?
Billions of years, potentially. That's important because for a planet to develop and sustain life, you need stable protection from radiation over very long timescales.
Now, Earth probably had a basal magma ocean early in its history, right?
Yes, shortly after formation, but Earth is relatively small, so as it cooled, that magma ocean eventually solidified. Super-Earths, though, with their higher internal pressures and temperatures, could maintain these basal magma oceans for much, much longer, potentially throughout their entire lifetime.
This has pretty significant implications for the search for habitable worlds.
Absolutely. One of the factors in determining whether a planet might be habitable is whether it has magnetic protection. Without a magnetic field, a planet's atmosphere can be stripped away by stellar wind, making it hard for life to survive on the surface. If super-Earths can generate magnetic fields through basal magma oceans, that potentially increases the number of worlds that could harbor life.
How do we test this theory?
That's the exciting next step. We need to actually detect and measure magnetic fields around exoplanets, which is extremely challenging with current technology. But next-generation telescopes and instruments might be able to do it. Professor Nakajima mentioned she can't wait for future magnetic field observations of exoplanets to test their hypothesis.
It's fascinating how interdisciplinary this research is, combining experimental physics, quantum simulations, and planetary evolution models.
That's what makes it so robust. They weren't just working on theory, they actually recreated the conditions inside super-Earths with laser shock experiments at the Laboratory for Laser Energetics at the University of Rochester. Then they combined that with computational modeling to understand how these conditions would evolve over billions of years.
And this was challenging work for the team, wasn't it?
Very much so. Professor Nakajima mentioned this was her first experimental work. Her background is primarily computational. She credited support from collaborators across various research fields for making this interdisciplinary work possible.
It's a great reminder that some of the biggest scientific questions require bringing together expertise from multiple disciplines.
Absolutely. Understanding planetary interiors, magnetic field generation, and habitability requires geophysics, astrophysics, planetary science, and material science all working together.
So the bottom line is, super-Earths might have a built-in radiation shield that we didn't know about, potentially making more of them candidates for harboring life.
That's exactly right. It expands our understanding of what makes a planet potentially habitable and gives us new things to look for when we're evaluating exoplanets as possible homes for life.
Well, that wraps up today's edition of Astronomy Daily. From solar storms to baby stars, Chinese space technology to hidden magma oceans on distant worlds, it's been quite a journey through the cosmos.
It really has. And remember, if you're in the northern tier states of the USA or Canada tonight, keep an eye on the sky for those auroras from that solar storm. Could be quite a show.
Thanks for joining us. For the latest space and astronomy news delivered fresh every day, be sure to subscribe to Astronomy Daily. You can find us on our website at astronomydaily.io or search for us on your favorite podcast platform.
Until next time, keep looking up.
Clear skies, everyone.